Hello, in the last lesson we went over what a radian is. And then we went around a circle and we kind of marked off where 1 radian, 2 radian, 2 radii, 3 radii, and so forth, where they were. But we really didn't get into radians that we actually use in math and physics. So in this lesson we're going to start looking at some common angles that occur with radians. But before we do that, I want to take you through a small exercise. If we look at this right here, I want you to fill this out. I'll put a link into the description where you can download this, or you can just pause the video and work the problems out on your own. You can draw it by hand. And then we've got it back here. So pause the video, give that a try, and then we will go over it together. All right, I take it that you've given that a try. Let's take a look and see what I've got here and do the shady work. So I've already kind of gone through and marked some of this down so that way we could do this quickly. If this is 1 whole, what is 1/2? Remember, when we divide something in two, we're cutting it in half. Pretend like that goes through the center. I did this with just using a ruler, so I was a little bit off, but right here is 1/2 shaded. Next, once again, when we're dealing with fractions, it's helpful to define what a whole is. This full circle is 1 whole. 1/4 of that is cutting it into 4 equal parts and shading one of those parts. If this is a whole, shade 1/3. Notice we're stemming from the center here to get 3 equal parts. Pretend like that's equal. And there it is, shaded. If this is 1 whole, what is 1/6? So 1/6 is 1/2 of 1/3. So I've got my third still marked out like I did above, but now I'm going to cut each one of those pizza slices in half, and that is 1/6 shaded. It doesn't really matter which one you shade, just only shade one. And now notice down here at the bottom, we are going to start changing what we're defining as a whole. So now here is a whole. Okay, it's half a circle, but that's what we're going to consider to be 1 whole. So 1/2 of that whole right there is going to be taking that shape that I have and cutting it in half and shading one of those. Now, I do this, well, let's jump to 1/4 real fast here. If this is 1 whole, this is 1/4. Okay, we take what was a half up above, and we're going to split each piece in half there, and this is 1/4. Now, sometimes I will get this as an answer when I give this to my students. They will say, there's a half, and then now we've gotten to 4 pieces. And that's what I want to correct here. This is not 1/4. Notice these are not equally spaced out. We have to draw our lines from the center of what was a circle there in order to get fourths there that are equal pieces. Next, if this is 1 whole, shade 1/3. So I've divided the whole up into thirds, and one of those gets shaded. And just like in the last one where we did a 6 up here, 1/6 is going to be half of the third. So I drew that 1/3 mark there again, and then cut it in half again. There is 1/6. Now we've got one more to do on the back here. Let's take a look at that. If this is 1 whole, shade 1/2. So now we've got still, once again, half a circle is being defined as 1 whole, but then they give us a full circle here. I drew these lines in later, but they give us this full circle. So really, if this is 1/2, then a full circle is 1 whole. I'm sorry, not 1 whole, it's 2 wholes, right? So here's a half a circle that's a whole. That means I can just kind of draw that line and ignore the bottom half, and it becomes like the problems on the front at the bottom. So half of this is going to shade like so. If this is a whole again, once again, shading 1/4, we're going to be cutting that half in half again. There's 1/4. If this is 1 whole, 1/3 gets shaded right here. And then if this is a whole, 1/6 is half of 1/3, and it gets shaded like that. Okay? I do those for a reason, and that's because the way I teach the unit circle. As we introduce the unit circle, we want to start to recognize where our common angles are. And it's not always easy for students to just rote memorize this stuff. So I want to start the unit circle with knowing our angles in radians, and then we're going to build off of that and get trig values in there. But right now, I just want to make sure that you know how to come up with the angles that are common on the unit circle. And so I use a lot of techniques dealing with fractions like we just shaded out here to figure out what angles are where on the unit circle before we start memorizing things. So maybe you've heard of the unit circle before, and that's why you're here. You're trying to get extra help on it. Maybe you've never heard of it before. Either way, we're going to start today off like you've never seen it before, so that way you can start fresh. Okay, so let's take a look at this circle right here. Now, a unit circle is a circle with a radius of 1 unit. That's why we call it a unit circle. But before we really get into unit circles in general, I just want you to know how to come up with the angles that go around this circle. I'm going to start this one off in degrees, because we can talk about this unit circle in degrees, or we can talk about it in radians. So remember that talking about our angles in standard position, if you haven't seen that, go back and watch that video. This right here would be 0 degrees if I just drew a ray on this that didn't spin anywhere. 0 degrees is where we start off with. Now if we go a full circle is 360 degrees. So 0 degrees and 360 degrees are coterminal angles. Now if I go halfway to 360, I go to 180 degrees. Once again, this is where I'm developing that, if this is one whole, then this right here is half of that whole, 180 degrees. Now, like we did on that last problem, if I just look at the top half of the circle and say that's one whole, well, halfway to 180 is 90 degrees. And then from 90 degrees, notice each one of these 90-degree angles, I've got one 90 degrees, I've got two 90 degrees, that's 180, and then I've got the third 90-degree angle right here is at 270. So I'm just adding from 0 to 90, add 90 to that, I get 180, add 90 to that, I get 270, add another 90, I'm at 360. And I know you may know this already in degrees and like, hey, this is super simple, I can just fill it out. But I'm trying to show you how I'm going to develop this using radians. So halfway between 0 and 90 is 45 degrees. And if I trace these out, I'm going to go ahead and trace these out in purple. My 45-degree angles. So I don't know if it shows up on camera any different because it is kind of a dark purple. It may or may not. But each one of these is a 45-degree jump. So 0 to 45 is 145. Add 45 to that, you're at 90. Add another 45, you're at 135 degrees. That's 90 plus 45 degrees. Add 45 to this, you're at 180. Add 45 to this, you're at 225. Add 45 to 225, you're at 270. Add 45 to that, you're at 315 degrees. And add 45 to that, you're at 360. Okay, so that is my 45-degree marks going through there. Now, if I take this 0 to 90 and look at it again, this is 1/3 of the way to 90. So 1/3 of 90 is 30 degrees. So each one of these marks are going to be 30, add another 30, add another 30 as we go through here. I'm going to highlight those in pink real fast. All right, there they are highlighted in pink. And so I go 30 degrees here, add another 30, you're at 60. Add another 30, you go to 90. So you're kind of ignoring the 45-degree line right here. And we are jumping by 30 degrees. You count the ones, though, that are on the quadrant there. So 30, 60, 90, 120. Skip over the 135, add 30 to the 120, you're at 150. Add 30 there, you're at 180. Add another 30, you're at 210. Another 30, you're at 240. Another 30 takes you to 270. Then 300. Then 330. And then finally 360 as you go back around. All right, so that is all the angles in degrees. That's how we worked it out. I just printed this off too large. Let's zoom out a little bit more. There they all are. Now I want to take you through going through these in radians. And we're going to do the exact same thing, but now we're going to talk about it with radians. And I will try to put a link. If you want some of these unit circles to print out, I'll put a link in the description so that way you can get them there as well. So let's go back. And now we're going to do the exact same thing, except for this time, we're going to do it with radians. So if I start off here at 0, I still have 0 radians. That does not change. So we got 0 radians right here. If I go all the way around the circle, remember from the last video, all the way around the circle gives me 0 to 2 pi. There are 2 pi radians that fit into that. If you don't remember that, go back and watch my video on what a radian is. That will help you out there. So 0 all the way around the circle is 2 pi. Now if I go just halfway around the circle, I'm going to go half of 2 pi. So 2 pi times 1/2, well, put this over 1 and multiply, I get 2 pi over 2, which equals pi. So halfway around the circle is pi radians. And then halfway to pi, so I'm just looking at the top half of the circle again, halfway to pi is going to be pi over 2. How do I get that? I say, what is pi times pi, times 1/2. Put that over 1, multiply, and we get pi over 2 radians. So that's going to be pi over 2 right there. So just like on the last one, when we talked about degrees, remember we go 0 to 180, cut that in half, and 1/2 times 180 is 90. And then we went around and counted. We said that's 190, 2 90s, 3 90s, and then 4 90s. I'm going to do the exact same thing right here. This is 1 pi over 2. Go another pi over 2, or 90 degrees if you're thinking about it in degrees. 1 pi over 2, 2 pi's over 2. Remember that 2 pi over 2, if we're looking at it mathematically, 2 pi over 2 is the same thing as pi. So that matches up there. That's good. So 1 pi over 2, 2 pi over 2, this is going to be 3 pi over 2. And then lastly, we're going to be at 4 pi over 2, which is 2 pi. And so that all matches up there. The next thing I want to do, and the last one we said this is 0 to 90, half of that is 45. I'm going to say, what is half of pi over 2? So if I say half of pi over 2, pi over 2 times 1/2 is pi over 4. So that's this angle right here, pi over 4. Let's go through and color these 45 degree or pi over 4 radian marks in purple again. All right, there they are, kind of highlighted in purple. I think you can see that. But as I go around, I'm going to stop at each 45 degree increment, or as we're learning radians, we call that a pi over 4 increment, and count them out. So this is 1 pi over 4, 2 pi over 4, that reduces to pi over 2. And this is going to be 3 pi over 4. This is 4 pi over 4, same thing as pi. This is 5 pi over 4. This is 6 pi over 4, right? Oops, I accidentally marked that in the wrong spot, didn't I? 5 pi over 4. This is 6 pi over 4, which is, it reduces to 3 pi over 2. And then we have 7 pi over 4 right here. And then 8 pi over 4 is at 2 pi, so that matches up. So that covers my 45 degree marks in there. The next thing I'm going to do, remember on the last one we said, we found out this was 30 degrees by saying it's 1/3 of 90, or 1/3 times 90. We're going to do the same thing here, except we're going to take 1/3 of pi over 2. So 1/3 times pi over 2 is what I want to do now. Here's pi over 2 times 1/3. That gives me pi over 6. So this line right here, that's pi over 6. And I'm going to go around and highlight all of these 30 degree or pi over 6 marks here. So let's do that now. So there we go. And I'm just going to count at each stop. Remember, we're skipping over these pi over 4 or 45 degree marks. But I'm going to say this is 1 pi over 6. This is 2 pi over 6. And I do want you to reduce that, but I don't want to lose count. So what I do when I'm teaching somebody that's first learning this is just to count and mark them all out and then reduce them. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6 right here. Now I wrote them on the inside because I'm going to go through and make sure that they don't need to be reduced. All right. So this was 2 pi over 6. That does reduce. I should have wrote it on the inside, but I didn't. It reduces to 1 pi over 3, or just pi over 3. The pi over 2 does check out with this right here. I just use this as a checkpoint. This should equal that. 3 pi over 6 does equal pi over 2. So that's already reduced up there. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 does not reduce. I can just write it like it is right there. 6 pi over 6, the 6's cancel. I get just pi. That does equal pi right there. And then I get 7 pi over 6. That does not reduce, so I can write 7 pi over 6 right there. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. That checks out. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 does not reduce. I can just write it there. And 12 pi over 6 does reduce to 2 pi, so that checks, okay? That is all of our angles written out in radians on the unit circle. Those are our most commonly used angles, and that's why it's important to know them. But more importantly, we're going to use this to figure out what are the sine, cosine, and tangent values of those angles. That's what we'll look at in the next video, but I want you to get some practice, okay? It doesn't come so easily the first couple times you do this. So print out a couple of those sheets. If you're in my class, you can just ask me for extra ones. If you're not, you can print them off in the link below that I'm going to put in the description. And then just go through and practice writing out those angles in radians. You can practice in degrees if you want, although in my class, we will not use degrees that much. We're going to mainly stick with radians, okay? I hope you have a good time doing this, and thank you for watching.